Alright, good afternoon everyone. So today we'll be looking at oxidation reduction reactions. Alright, so basically I'm going to discuss it in terms of gain or loss of electrons, increase or decrease in oxidation number. We're also going to talk about reducing oxidizing agents. Alright, and definitely we're going to look at some different reactions that demonstrate oxidation and reduction. Alright, so you can be fully prepared and appreciate the concept of oxidation and reduction reactions. Alright, so not every reaction entails oxidation and reduction, but most reactions will that involve in chemistry will have some amount of oxidation and reduction going on. Alright? So oxidation is the loss of electrons of an element. Right? Oxidation is the loss of electrons, alright? Right? So it simply means that reduction
is a gain.
Good. So take those two definitions from the word in terms of oxidation. So oxidation is the increase in oxidation number of an element in its free state or in a compound, alright? Alright, so oxidation also is the increase in oxidation number. Alright, so remember if we go back to maths on the number line, negative numbers will be lower than 0, positive numbers will be higher than 0. Right? Because as I said before, oxidation number, it can be negative, it can be positive, and it can also be 0. Alright?
0 is when it's in the pure state.
Good. In the element in its pure natural state. So like for oxygen in its free state would be oxygen gas. For nitrogen it would be nitrogen gas. Alright? For the metals, they would be the pure metal when you extract them from the ore. Right? Because remember that metals don't really exist in nature in pure form. Well, most of them. Like you have the fancy one like gold and platinum will exist in the pure form, which are unreactive. But most of the other metals, because they are so reactive, they exist in compounds, ionic compounds in the earth. Alright? So reduction is the decrease is a number Alright? So decrease. Reduction, decrease. Alright? Oxidation, increase in oxidation number. Alright? Good. Then next thing that I need to talk to you about, oxidizing and reducing agents. Alright? And for the agents, can I erase this now? Go ahead. Alright, so those are oxidation and reduction. Alright? We should talk about oxidizing. Oxidizing and reducing agents. Alright? Now, I'm going to discuss them in terms of oxidation number, right? Right, but they could also be discussed in terms of electron loss or gain. But I'm going to leave you to read that, right? But so as you can see, the oxidizing agent now. So oxidation is the increase in oxidation number, right? But the agent is actually the compound that caused that increase.
What is it? Agent.
An oxidizing agent causes the oxidation number of an element in its free state to increase. Right? While so decrease, right? Good. So we're going to look at some rules to follow in determining oxidation numbers. Because what's going to happen is that you will know what oxidation and reduction, you will know the definition, right? But sometimes you have to have the knowledge to know that some compounds probably just have one fixed oxidation number in all compounds, while some have variable oxidation state. Alright? So you have to have those rules and become familiar with them. So there are actually 7 rules listed in this book that I'm going to take my time to go through on the board before we just start discussing questions and stuff. Alright? Alright, so rule number 1, right? The oxidation number of each atom of an element in its free state is 0. Right? Example, talk about oxygen gas in the air. So oxygen in this case gone to 0 in this case, right? Hydrogen, or let's use nitrogen gas, right? The nitrogen gone to 0, the oxidation state that is, right? or the oxidation number. Oxidation, if I use oxidation number or state, interchangeable, alright? So the oxidation number of elements in the free state is 0, alright? So we can also use the halogen like bromine, Br2. So let's probably just use like a ON for oxidation number. Just for abbreviation's sake, right? So the ON for bromine, Br 0, alright? And if you have other metals like if it's sodium, solid, metal, oxidation state, or number. Following?
The elements are
In
zero.
their free state. So how they exist in nature in their pure form is 0. You gotta remember that
And
oxygen don't exist as oxygen atom in its free state. It exists as oxygen gas. That's how you will find it in the earth naturally. Alright? So if you go to like even iron, Fe solid by itself, oxidation number equals 0. So all these are example of rule number 1, right? If you have copper, solid, oxidation number equal to 0. So O dot N stands for oxidation number. Following? Good. Alright, let's move on to rule number 2. The charge and the ion. Example. So you have sodium chloride, right? The oxidation number of sodium is +1. Oxidation number -1. Because the charge on the ion would have been sodium plus Cl minus. Alright? And do you remember how we get these charges? So the sodium plus here is because it's a group 1 element and it loses 1 electron to become stable. Become a stable cation. Remember that? That is why sodium is a group 1 metal, so the charge will be +1. So other group 1 metals are potassium, lithium. Alright? So lithium, sodium, potassium, they are group 1 and they will give a +1 charge as metals. Right? So the oxidation number of those metals in compound will be +1. Likewise, if you go to group 2, you have magnesium, say magnesium bromide. This I want an example. So in this case, magnesium bromide, I want to use magnesium hydride. Deliberately want to use this one, alright? Pay attention, parts, alright? Good. Magnesium hydride, alright? So, in this case, this is not hydrogen gas. It's a halide, it's 2 halide ions, right? So this breakdown, this is actually Mg2 plus H minus, two of them. Another plus here. Right? So these are 2 halide ions, right? They are hydrogen -1 charge, right? So the charge, the oxidation number, in this case for magnesium, is 2 plus. The oxidation number for hydrogen is -1. And not 0. I'm using this example deliberate because this is not hydrogen gas, or this is not hydrogen in its free state, it's hydrogen in an ionic compound. So that is why it's actually hydride anion and not hydrogen gas. even though I see H2 here, it's actually within this compound. It's one compound. Following, I want you to get those basic concepts, you know. Alright? Those are stuff that in the previous test, students have probably showed that they didn't fully understand. Like, if something is in a compound or in its pure form, what's the difference? Alright? So remember that, as I said before, these are monoatomic ion, right? So it's just one element make the charge. So monoatomic ion are like group 1, group 2, just like losing the electrons. So group 1, if the metals lose 1 electron, or group 2, if they lose 2 electrons, they will form monoatomic positive ions, cations, which would give the oxidation number would just be the charge on the ion, right? So we can fear to conclude that group 1 metals, the oxidation number in their compound will be +1. For group 2 metals, the oxidation number for those compounds, for those ions in their compound will be +2. Right? For group 7 ions, those are the halogens. Alright, so all the halides like chloride, bromide, iodine. So they have fluoride, group 7. Right? This is fluoride, chloride, bromide, iodine. Alright, so you can see that these are all monoatomic anions. So anions are negatively charged. So the oxidation number of all these monoatoms would be -1. Alright? So oxidation number -1, oxidation number. Following? Any questions? So those are monoatomic ion. Right? Good. Now remember that they also have polyatomic ions such as sulfate, nitrate, clear? And phosphate and those stuff. Alright, but we'll talk about those in a different rule. Alright? Now, rule number 3. The oxidation number of hydrogen in a compound or polyatomic ion is always +1 except in metal hydrides. Alright? So rule number 3. So let's talk about rule number 1 was about elements in their free state. Rule number 2 was about monoatomic ion. Rule number 3 is about hydrogen. Alright? So you can see that hydrogen is so special, it have a rule for itself. Alright? So number 3, hydrogen +1 in compounds except in metal hydride. Hydride. Where the oxidation number is -1. Alright? Good. So, examples here. If we have water, popular compound for oxygen, the oxidation state of hydrogen is equal to +1, oxidation number or state of oxygen is -2. Alright? We have ammonium. So this is a cation, right? The oxidation number of hydrogen is equal to +1. Alright? So the only time when the oxidation number of hydrogen is in metal hydride, so if we go sodium hydride, oxidation number of hydrogen is -1.